Alright, we're going to talk about angles and parallel lines and when parallel lines form different sets of angles, what kind of relationships they have. So to start off, let's talk about what parallel lines are. Parallel lines are going to be on the same plane. So if we look at plane ABCD, or plane ABC, and we look at line AB, or AD, and line BC, you notice they're going to be on the same plane and they're going to go on infinitely and never intersect. Then you have skew lines. Skew lines are going to be on separate planes. So I'm going to look at plane EFG in the back, and I'm going to look at this line HG. And then I'm going to look on plane ABC in the front, line AD on ABC. And skew lines are going to be on separate planes, and they're never going to intersect. What we're going to focus on today is parallel lines when they never intersect. First word you need to know is a transversal. A transversal is going to be one line that goes through two or more lines. So for example, if I have, here's two lines, and I have one line that goes through it, this line right here is my transversal. So a transversal is a line that intersects two or more lines. So if we look at this picture right here, what is the transversal of lines L and M? Well, here's line L, here's line M, and if you notice, line O intersects both line L and line M in two spots. So we're looking for the line that crosses two other lines. And the transversal of line L and M was our line O. If we're looking for the transversal of M and O, well, here's M, here's O, and if you notice, line L intersects M and O each line. So the transversal of M and O is line L. And the reason it's going to be important to identify a transversal is because we're going to have all these different angle relationships formed by a transversal. The first angle relationship is called alternate interior angles. And these are going to be pairs of angles that are on opposite sides of the transversal. So here's our transversal. Here's side 1, opposite side 2 of the transversal. And alternate interior angles are going to be inside the two lines. So inside here on opposite sides of the transversal. They're going to form a Z. So if we look at the Z here, we have this angle and this angle inside the Z. And if we do a backward Z, we'll have this angle and this angle, 4 and 5, that form the Z. So in our picture, our alternate interior angles are going to be angle 3 and angle 6. And if we do the backward Z, we have angle 4 and angle 5. And the way that we can recognize alternate interior angles is if you draw a Z and a backward Z, they're going to lie on the inside of those cusps of that Z. You're going to find alternate interior angles here and here, or you're going to find them here and here. So here and here are alternate interior angles, and here, inside that Z. The next angle pair that's formed by two lines in a transversal is alternate exterior angles. And they're going to be on the opposite sides of the transversal. So you're going to have one on this side, one on this side. And they're going to be the outermost angles. So you're going to have angle 1 is an exterior angle, and on the alternate exterior side is angle 8. So angle 1 and angle 8 are alternate exterior. And then our other pair is angle 2 and angle 7. And they're on the outermost edges. So they're on the outermost edges, or the outermost exterior, and they're on opposite sides of the transversal. So I always picture my hands going like this and this, like jazz hands. Corresponding angles. They're called corresponding angles because they correspond with one another. They're basically on the same line, or on the same angle, but different lines. So they're going to be on the same transversal, same side of the transversal. So they're going to be either on this side or this side. And they're basically in the same position. So let me explain what I mean. If I look at angle 1, we have the top left corner. I'm going to move down a line to the top left corner, and I have angle 5. So angle 1 and angle 5 are corresponding. Then if I look at the top right corner, angle 2, move down a line, top right corner, angle 6. Those are corresponding. So they're in the same position, but different lines. Top right, top left, top left. We also have bottom left, angle 3, and it's bottom left, angle 7. They have the corresponding positions. Bottom right, angle 4, bottom right, angle 8. So the way I identify them is I pick an angle on the top line, then I move down to the next line, in the same position. So pick an angle, angle 1, move down to the next line, same position, angle 5. The last angle relationship we have are called consecutive, and let's change this, consecutive interior angles. And if you know what consecutive is one right after the other. So we're going to have one angle inside the two lines. Oops, move that up. We're going to have one set of angles inside these two lines, one right after the other. Consecutive, one right after the other, interior inside the two lines. So angle 3 and angle 5 are one right after the other inside the two lines. And angle 4 and angle 6, one right after the other inside the two lines. So in order to identify them, this is pretty cool, I can draw a C for consecutive, and they also make the I for interior. So consecutive interior angles lie inside the I for interior. All right, so let's see if you guys can figure out the answers to listing the pairs of angles that fit these descriptions. So corresponding angles. Pause the video and see if you get what I get. For corresponding angles, I have angle 1 and 3, same line, or same position, different lines. I have angle 2 and angle 4, same position, different lines. I have angle 5 and angle 7, same position, different lines. And I have angle 6, angle 8, same position, different lines. That's corresponding. Alternate exterior. Pause the video, see if you get what I get for alternate exterior. Alternate exterior angles are on opposite sides of the transversal, outermost edges of my corners. So I should have angle 1 and angle 8, and angle 4 and angle 5. All right, see if you can correctly identify alternate interior angles. Pause the video and see if you get what I get. Alternate interior angles, I always look for my forward Z, so angle 2 and angle 7. And then I look for my backward Z, angle 6 and angle 3. Those are my alternate interior. All right, pause the video and see if you get what I get for consecutive interior. Consecutive interior, I look for my C, angle 6 and angle 7. Then I finish it up with my I, angle 2 and angle 3 for consecutive interior. Now, if we have parallel lines and then we have these angle relationships, they're going to have special values. The first one is the corresponding angles postulate. It says that if two lines are parallel, and we know that they're parallel because they have those arrows that tell us they're parallel. If we have two parallel lines cut by my transversal, then the corresponding angles, so the example they gave us was angle 1 and angle 2, they're corresponding. They're going to be congruent. So algebraically, if we had a set of corresponding angles, and we didn't know one was, let's say one was 3x plus 2 and one was 7x minus 7. And if we knew these lines were parallel and we had to solve for x, we would set 3x plus 2 equal to 7x minus 7, or whatever I said. I can't even read my own handwriting. All right, the next relationship is alternate interior angles. And that says that if you have a set of parallel lines that form alternate interior angles, then those alternate interior angles are also congruent. So angle 3 is congruent to angle 4 if the lines that form them are parallel, or if we had on the other end of it these two angles, let's call them 5 and 6, then 5 and 6 would also be congruent because they're alternate interior angles. All right, the next one, this is the one that's going to be different, and this is the one that is notoriously messed up all the time, and that is the consecutive interior angles. Consecutive interior angles are not going to be congruent when these two lines are parallel. They're going to have a relationship of supplementary. So even look at the angles. This angle 5 and this angle 4. If I were to pull them apart, do you see that there is no way that this acute angle is going to equal this obtuse angle? There's no way. It's just like when we had a linear pair. Remember a linear pair, two lines that form, or two angles that form a straight line? Remember the one was always acute and the other one was always obtuse? You guys always set them equal to each other? But they're not equal to each other. They're clearly not equal to each other. This one's itty bitty. This one's biggy biggy. So they can't be equal. They're going to have a sum of 180. They're going to be supplementary. So if you have two lines that are parallel, and those two parallel lines form consecutive interior angles, then those consecutive interior angles are supplementary, not parallel. All right. Then we have alternate exterior angles. If you have two parallel lines, once again, that form those alternate exterior angles, then alternate exterior angles will be congruent. So in this example, parallel lines, we know they're parallel, cut by a transversal, form congruent alternate exterior angles. And then finally, the perpendicular transversal theorem says that if a transversal is perpendicular to one or two parallel lines, so in this example, J is perpendicular to H, and the lines are parallel, then it is also perpendicular to K. And the cool thing about this, if you ever see 90 degrees here and 90 degrees here, and these are parallel, then all of these guys get to be 90 degrees. So it makes the problems really easy. All right, let's do a little practice with this and see if you understand. It says refer to the figure at the right and assume that A is parallel to B. So here's A, here's B, and I'm just going to make my little arrows so we know that they're parallel. And I want you guys to see, pause your video and let's see. If angle 1 is 82, how do I find the measure of angle 5 here? Okay? Well, the measure of angle 5 and the measure of angle 1 are going to be congruent because angle 1 and angle 5 are corresponding angles. And when corresponding angles are formed by parallel lines, then the corresponding angles are congruent. So if 1 is 82, then 5 is also 82. Okay? Pause the video and see if you can figure out number 2. It says that the measure of angle 4 is 130. Find the measure of angle 6. The measure of angle 4 is 130. Find the measure of angle 6. Well, angle 4 is 130, and ignore the picture. It's a bad picture because this is obviously not 130. That's an acute angle. I messed up there. Then the measure of angle 6, well, let's identify the angle pair. Those are consecutive interior angles. And when consecutive interior angles are formed by parallel lines, which it says A was parallel to B, then consecutive interior angles are supplementary, not congruent. So if angle 4 is 130, and these two are supplementary, then we take 180, subtract that 130, and we'll get 50. Next example, pause your video. I don't have this on your notes. You guys can just write it to the side if you'd like. But it says the measure of angle 2 is 60. So let's find the measure of angle 7. So the measure of angle 2 is 60. Let's find the measure of angle 7. Well, 2 and 7 are alternate interior angles, or exterior angles. And alternate exterior angles are going to be congruent when the lines that form alternate exterior angles are parallel. So if angle 1 or angle 2 is 60, then angle 7 is also 60. All right, the last example, I want you to pause your video and see if you come up with the same thing I do. Be very careful when you're setting up the algebra for this one. We're not always setting everything equal to each other. All right, so we have find the value of x. These lines are parallel. These angles, 120 and 3x, are not going to be congruent because they're consecutive interior angles. And consecutive interior angles are supplementary when the lines that form them are parallel. And these lines are parallel, so consecutive interior angles are supplementary. So this angle 120 plus this angle 3x are going to equal 180 degrees. They're supplementary. Subtract my 120 from both sides. So I get 3x equals 60. Divide by 3. So I get x is 20. I'm going to plug that x back in to make sure I did it right. 120 plus 3 times x, which was 20, should equal 180. 120 plus 60 should equal 180. 120 plus 60 is 180. So I did this correctly. So when you're setting up your algebra and your practice worksheet that you're about to do, make sure that you know the relationship, identify the angle relationship, then look at your notes and make sure that you know which relationship it has. Basically, you're going to set all the angles congruent to each other or equal to each other unless they're consecutive. If they don't have an angle relationship, like say I gave you this angle and this angle, you're going to have to use your angle relationships to find a missing angle. All right, good luck with your worksheet.